Alright, this is a mid-year exam practice walkthrough 1 to 15. This is actually my second recording of this because the first recording I was watching it and there's a lot of it recorded a lot of my breathing. I can't guarantee if there's breathing in this video, I'm out. I I'm not out. I mean, I'm not recording another one. Just deal with it. That's what you get with my scuffed mic, my scuffed headset mic. All right, number one. The height of a typical kitchen table is approximately what? All right. Uh, so if you look at the choices, 10 to the -2 meters, that's actually one 1 centimeter. All right. There's no goddamn way my kitchen table. You're telling me my kitchen table is 1 centimeter? Get out of my house. All right. Get out of my house. All right. So 0 meters is 1 meter. And that makes a bit more sense. That makes a bit more sense. You know how you guys used meter sticks before. A meter stick is 1 meter. 10 to 1 meters. You're telling me my kitchen table is 10 meters? This is 100 meters. So there's no way these two choices even remotely resemble my kitchen table, and neither does a 1 centimeter kitchen table. So the answer is B. The most logical choice is B. Scalars the vector as what is to what. And so the scalars you've learned so far, again, scalars have no direction. So scalars have the scalars you learn are distance, speed, and time, velocity, displacement. So these are vectors. These are vectors: velocity, displacement, and acceleration. Distance is the scalar version of displacement, and speed is the scalar version of velocity. Make sure you remember the units as well. A ball is thrown vertically upward with an initial velocity of 29.4 meters per second. Was the maximum height reached by the ball? So you throw something like that. Alright, so my initial velocity is 29.4 meters per second. We know that if it's in the air, if it's a projectile, we know gravity is acting on it. And we also know at my max height, my velocity is 0. So my final velocity is 0. And we want to figure out what d is. So the formula we're going to use is Vf is equal to Vi plus 280. Actually, it's Vf squared to Vi squared. So Vf is 0 in 29.4 squared plus 2 negative 9.8 d. I'm just going to write it over here. So 29.4, I'm going to round this to 30. So 30 squared gives me 900. And then I'm going to round this to 10. So plus 2 times 10 is 20. So minus 900. Oh, this is going to be negative, by the way, because 2 times negative 9.8 is negative 20. Or negative 19.6. Doesn't really matter how you do it. Negative 900, negative 20, negative 20, negative 20, and you're going to get 45. Somewhere around there. 45 meters, so the answer is C. Close enough. 4. A 5 kilogram sphere, starting from rest, falls freely 22 meters in 3 seconds near the surface of the Earth. So comparing the acceleration, sure. So you start from rest, okay, and you fall freely. So you fall a displacement of negative 22 meters. Time is 3 seconds. And if you want to know what acceleration is. So you're starting from a certain point, and 0 is your reference point. So if you go below 0, if you fall below 0, you're going to have a negative number. You're going to fall a negative displacement. And on the other hand, if you go up, you go above 0, then you're positive. And then you're positive. So the kinematic equation we're going to use is most likely this one, -22, 0 plus 1 half a 3 squared, -22 is equal to 9, 4.9 a divided by this, a is 5, somewhere around there, somewhere around 5. Yeah, yeah, somewhere around 5. And so, well, what's this compared to Earth? It's 1/2 as great. So the answer is C. 5. Traveling on a straight road, VI is 15 meters per second. VF is 21 meters per second. T is 12 seconds. Total distance traveled by the car is what? So there are two ways we could solve this. The easiest way is just do this. V bar is equal to VT, and we know V bar is VF plus VI divided by 2, because that's what V bar is. V bar is average velocity. How do you take the average of two numbers? Add them both up, divided by 2. In this case, it's velocity. So 21 plus 15 divided by 2, D over 12. 36 divided by 2. Actually, instead of me being shortcuts, I'll just write everything out. 36 divided by 2, 18 times 12 times 12. D is going to be 216 meters. All right, that's the answer. Alternatively, let me just erase everything. Alternatively, we could have solved for acceleration first, right? Because, well, our three kinematic formulas do not have all this in them. They all require you to know at least acceleration. So, well, let's say we want to find acceleration first. Vf is equal to Vi plus At. All right, 21 is equal to 15 plus A 12 seconds, I forgot, minus 15, 6 is A 12 divided by 12, and we get 0.5 A meters per second squared. So now that we know acceleration is negative, actually not negative, 0.5 meters per second squared, well, now we can use any other formula. And I'm going to use this one. So we know D, we want to find out what D is. VI in the problem says 15. T in the problem says 12. Plus 1/2 A is 0.5. That's how we got it when we solved for A. And T squared. So 15 times 12 is 180. 1/2 times 25, 0.25 times 12 squared is 32? 36? Nah, 36. So you still get the same answer. So one way is short and simple. The other way requires more work, but you still get the same answer. 6. And if you're wondering why I'm rushing through a lot of this is because it's my second time doing this again. Hopefully it doesn't turn out scuffed. Hopefully. Please. So velocity is 0, right? Constant acceleration of 2 times 10 to the 1 meters per second squared. How long will it take the rocket to reach an altitude of 9.0 times 10 to the 3 meters? So D is 9 times 10 to the 3 meters. So they want to know what the time is, right? They want to know what the time is. So we have everything we need. We have 4 things. Can just use this formula right here. D is equal to that 9,000. This is the VI. That's 0, 1/2. That's 20 T squared. So 9,000 is equal to 10 T squared divided by 10. I get 900. Square root that. I get T is equal to 30 seconds. And that is A. That is A. So 7. Car is traveling west and decreases its speed from 30 to 23, so our initial velocity is negative 30 meters per second, and final velocity is negative 23 meters per second. T is 2 seconds. We want to figure out what A is. So you're going to use this formula. Negative 23 is equal to negative 30 plus A2 plus 30 plus 37 A2 divided by 2, 3.5 meters per second squared is equal to A. Alright, and it's positive, so it's going east. The reason why I gave my initial speed negative 30, because let's say it's going west. Right? And we got our final answer was positive, so it's eastward, right? That's why. Let me adjust. So 8. Ooh, motion graphs. Which graph best represents the relationship between the velocity of an object thrown straight up and the time that elapses while it is in the air? There's actually a very simple way to understand this. If you're throwing it up into the air, you have an acceleration. Your acceleration is negative 9.8 meters per second, right? From Earth's gravity. And we know on the VT graph, my slope is acceleration. If we look at choice A is saying my velocity stays the same over time. This is 1 second, 2, 3. My velocity is staying the same over time, which means there's no slope here. So choice A can't be right. It's saying that I'm not accelerating. It's saying my velocity is staying the same over time. And we know acceleration is change in velocity. B looks good. B looks like it's changing velocity. But a curved line in anywhere, a curved slope anywhere means that the slope is changing. This is constant. This is a constant value, right? This is constant, which means that you should have a constant slope. And if you have a curved slope, curved is changing equals change. Changing slope. Curve is a changing slope, right? So B and C can't be it because we know that acceleration is constant, but a curved slope means my slope is changing, and that means if a changing acceleration, right? If I have changing slope, I have a changing acceleration, then it can't be B or C. Let's understand why D is correct, right? As you go up, right? As you go up, you have a high velocity. Let's say start with high velocity, 20 meters per second, 30 meters per second. Let's go up. Your speed decreases until you get a velocity of 0. And at that point, at the max height, you start going back down. But your velocity going back down is now negative. It's now negative. And so D is saying you start at a high positive velocity, let's say this is 30, and then you go downward over time, right? You're decreasing your speed and you finally hit 0. And well, now, once you hit 0, you go to negative 10 meters per second. Well, you're in the negative direction now. This is negative 10. This is negative 30. So this makes sense. All right, this makes sense. Number 9, which has a positive acceleration for 2 seconds. So positive acceleration, so if we know on a VT graph, slope is velocity, then a positive slope means positive, no, slope is acceleration, I'm sorry. On a VT graph, slope is acceleration, positive acceleration. All right, so it's either going to be A or D, because A and D both have positive slopes. And negative slope, and this is a positive slope, right? And this is a negative slope. This is a negative slope, so negative slope equal negative, acceleration. All right. So this is true. Well, now, yeah. So it's either going to be A or D. B and C say that you have a negative acceleration for the first few seconds, but that's not what the problem wants. The problem wants a positive acceleration for the first 2 seconds. So now that we've crossed out B and C, we can rule D out as well. Because D is saying you have a positive acceleration for 3 seconds. So that's definitely not true. Alright. And a constant velocity, that's what constant velocity means. Constant velocity is no slope, not changing, and no acceleration. A is 0. Right? That's what this means on a VT graph. 10. A baseball is thrown at an angle 40 degrees above the horizontal. 48 degrees. Horizontal component. Vx is 12 meters per second. Magnitude of ball's initial velocity. So it says the horizontal component of the initial velocity is 12. And saying that what is the magnitude of ball's initial velocity? That's your total initial velocity. It's not saying vertical or horizontal. It's actually just saying initial velocity. So you can safely assume, well, you can't safely assume, but you can assume that it's your hypotenuse right there. So all you're doing here is using trig, right? And so your adjacent is 12, your hypotenuse is VI, and your angle is 40 degrees. Okay, and you're going to use the only trig function that you can use is cosine theta is adjacent over hypotenuse. And cosine 40 is 12 over VI times VI times VI cosine 40 is equal to 12 divided by cosine 40 divided by cosine 40. VI is 15.7 meters per second. I'm going off memory here. So if you somehow get a different number than 15.7, assume it to be true. Make sure your calculator is in degree mode as well, not radian, degree. So let's do 11. 11. A car traveling with a constant non-zero acceleration, non-zero, which means A is not 0, which best represents the relationship between the distance a car travels and time of travel. Sure, first thing you need to know. Acceleration, not 0, which means velocity is changing. Okay? That's what acceleration means. Acceleration means changing velocity. Alright, that's what it means. And on a PT graph, that's what this is. Distance is position. On a PT graph, your slope is velocity. Okay? Slope is velocity. Now, if I have, and for my velocity to be changing, it must be curved. So curved means changing slope. So a slope like this means I have a velocity, right? This means I have a velocity, and let's call this position 0 and position 12 or 10. And so if I'm going from a position of 0 to 10, then I have a velocity. I am moving. Well, if I'm moving, oh, scratch that. If this is a straight constant slope, it means that my velocity here is constant. Velocity is constant. That's what that is saying. But that can't be true. We know our acceleration is not 0. And then we must know that, well, if acceleration is not 0, we know that my velocity is changing. Alright? So this can't be true. So for a changing velocity, we need a changing slope. And for a changing slope, it needs to be curved. It needs to be curved. It needs to be curved. So the only choices left here is either A or C. The difference between A and C is that the acceleration is not constant. Is not constant. Why? Because what C is saying is, well, I go a certain distance, right? I go a certain distance, and let's say that's 5 meters, and then now I'm backtracking. So here I have a positive acceleration, it's a positive, and then here I'm now backtracking, I have a negative acceleration. Actually, in both cases you have negative acceleration. Both cases you have negative acceleration. Oh, I see. The question says car is traveling with a constant non-zero acceleration along a straight line. Alright, along a straight line. But what C is saying that you travel this way and then you go back. Alright, so it's going to be A. A is the answer. Again, you want a changing curve. You want a curved slope because it's changing velocity for a PT graph. Number 12. Which pair of graphs represents the same motion of the object? Now, if you're too lazy to remember properties of motion graphs, there's an easy way to think about it. You're either going to have graphs like this. This is saying the exact same thing. It's the same exact same thing. Or it's going to be like this. So these two graphs say the same thing. If you have a PT graph like this, then the VT graph of this is this. If you have a PT graph of this, then the VT graph of this is this. That's it. So if you're too lazy to even understand anything about motion graphs, just remember this and you'll get things right when you're asked to which graphs represent the same motion. But let's go into why this works, right? Let's go into why. We talked about this right here. Changing slope. It's a changing slope. And if it's a changing slope, well, we know that slope on a PT graph is my velocity, which means that I have a changing velocity here. And a changing velocity means I have an acceleration. So, is my velocity changing here? Let's number it. Hell yeah, it is. My velocity is for sure changing. I'm going from 0 to 5 meters per second. Right? My y-axis measures velocity. So my velocity is changing. Well, and we know that slope on a VT graph is acceleration. So I have a slope here, which means I have a non-zero acceleration. So that's why this works. This right here, PT, I have a constant slope, so constant slope, so constant velocity, because we know velocity on a PT graph is your slope, and that must mean my acceleration is 0. All right. Now, if my acceleration is 0, my velocity is not changing. That's what this is saying. This is saying that my velocity over time is always 5. So there's 1 second, 2 seconds, 3 seconds. My velocity over time is always 5. All right, so that's why that works. So the answer would be A, because A is this top one here. 13. Compared to horizontal velocity at point A, the horizontal component of the car's velocity at point B is what? Now, if you're a projectile, if you're in the air, your acceleration in the x direction is 0. And if your acceleration in the x direction is 0, then your velocity in the x direction never changes. Because gravity only acts in the y direction, alright? So if gravity doesn't act in the x direction and your velocity never changes, well, the horizontal component at point B is the same for the horizontal component at point A. So the answer is C. 14. What quantity has a magnitude of 0 when it falls at the highest point in its trajectory? It's from, so this path and they wanted to figure out, well, at this point, what is it? At this point, you still have an acceleration in the y direction. Your acceleration in the y direction is still negative 9.8 meters per second squared. That's always true. Gravity is always pulling on you. And your acceleration in the x direction is 0 at the highest point, well, at any point. Your velocity in the y direction at the top right here is 0. Your momentum is for sure not 0. Why? Because momentum is m times v. And if you're throwing it this way, your velocity in the horizontal direction is for sure not 0. Alright? So A can't be true. A is negative 9.8. B can't be true. P is at m times v, and we know velocity in my x direction is not 0. So P can't be 0. C can't be true. This is my velocity in the x direction. Otherwise, it wouldn't be traveling in the x direction. And so the only answer is D. My vertical velocity at my highest point in time is 0. 15. Red ball is thrown horizontally at speed for at a height of 3 meters, so at the same height, speed 8 meters. Oh, so we did this in class. You saw the GIF. So it was different. The GIF that you guys saw was you dropped it and then another ball was launched horizontally. But this is the same concept. And mass doesn't matter here at all when objects are falling. I demonstrated that with the paper on top of the textbook, and they fell at the same rate. Now, our velocity in the y direction, our initial velocity in the y direction is 0. In both cases, is 0. My height is the same. My height is 3, right? My height is 3 meters. And my acceleration in the y direction is also negative 9.8 meters per second squared. And so, what was the time both objects reached ground with? Well, if you use a kinematic formulas to solve for t, and use these values, what you're going to get is you're going to get the same exact time. It doesn't matter how hard you throw it horizontally, you're still going to reach the ground at the same time. Because what governs how fast you fall to the ground? Your acceleration due to gravity. Gravity makes you fall to the ground, otherwise you wouldn't. And so if all three of these three variables are the same, your time is going to be the same. Right, same. Alright, and that is done with 15. End of this video. Hopefully it's not scuffed.